How's everybody doing? Is the mic good?
Yeah.
All right, let's get started then. So I'm Sam Jones. I'm on Twitter at SamJonester. I'm a developer in Philadelphia. I sling code in a lot of different languages. I started out writing Java. I've done some others on the JVM. Lately, I've been doing a lot of Ruby and a lot of JavaScript. We even had the chance to write a little bit of Haskell, which has been cool. But regardless of what language I'm writing this week, my values as a developer, they never change. What I value the most is communication in the code that I'm writing, above all else. I work for TestDouble. TestDouble is a group of awesome people who like to write nice code. So if you'd like our help writing nice code, you want to write nice code with us, or you just want to learn what that means, we're on Twitter at TestDouble, or you can email us, hello@testdouble.com. I also organize a Software as Craft meetup in Philadelphia. I think it's a great community. It's focused on what, in my opinion, are more worthwhile topics than just the latest JavaScript micro-templating framework, which is why you're all here today at SCNA. So we've got a similar vibe going. So if you're free the last Tuesday of the month, stop by and say hi. Or pitch us a talk. We'd love to have you down in Philadelphia too. Today, I'm here to talk about conveniences. A convenience gives us the ability to do something with little effort. Conveniences make us more productive. They make life easier. But is that always better? So I'm sure you can think of examples in everyday life of things that are convenient, things that make life easier, but that have large repercussions, like maybe disposable plastics, fast food. What about Slack? So what about in the JavaScript that we write every day, though? What conveniences do we take advantage of, and which are taking advantage of us? In JavaScript, objects are pretty convenient. Using the new keyword to create an object is too hard, so we can use object literals instead. Convenient. New object with some properties, well, that's pretty convenient too. And to string or not to string, it doesn't really matter. And once we've got an object, it's also a breeze to define a new property on that object. And once again, you've got options. Convenient. Especially when you aren't sure what your key is. And we can define objects wherever it's most convenient as well. Like when we call this function here, it takes an options object. So we can do what's convenient and just define it in line. And changing values in a deeply nested object is a breeze too when you have libraries like Lodash to help you out. This one's straight from the docs. Don't even need to check for null along the way. Maybe this one's a little bit too convenient. All right, so functions are also convenient in JavaScript. Our object properties, they can be functions as well as values. And once again, we have plenty of options for getting it done. Convenient. We can call that function later just by accessing the property, even if we strip it off and pass it around and call it later. Convenient. And surprise, turns out that functions actually are objects as well. That one's pretty convenient. And we can use functions in convenient ways as well. Like here we provide a transformation to a higher order function, or to give a callback to an asynchronous function, or to define a promise chain with a function that needs to be executed later on. These are all pretty convenient. But let's be honest. Those basic principles, things that make objects and functions convenient, they allow us to do some really awful things in JavaScript. So that's what we're going to do today. We're going to write a function where we pick apart some of the more short-sighted conveniences and see if we can make a mess together. All right, so first we want our function to find the appropriate purchase order, and then we want to send an invoice for that order. And this is basically every function that we write as developers. We look up some data and then we do something else with it. But then something like this happens. We actually need to provide some query parameters when we try to find our purchase order. So we'll just do what's convenient. We'll put them into the function inline. But wait, turns out when we try to find our purchase order, we don't get back an order. We get back an order that's wrapped up in this result thing instead. But conveniently, we can just destructure the exact value that we need. But then we try to run the code, and we can't just send an order as an invoice. We actually need to try to send an invoice. But conveniently, to change an order to an invoice, there's one little status value that we need to change deep inside of this object. And we just saw how to do that with Lodash, so that's what we'll do here. But then it turns out we want the original result object with the status from sending the invoice, and it's turning into a headache. And the deadline for this card is fast approaching. And we have to get this done. So what do we do now? Well, functions have scope. So let's take advantage of that. Let's nest another promise chain inside of this one. And as long as we don't forget any returns along the way, we're good to ship. We got this done just in time. Our boss is going to be so happy. All thanks to some of JavaScript's conveniences. At least that is until we try to send it through. We try to deploy it, and our CI pipeline tells us that we haven't tested this function, that code coverage went down. The deadline's still coming, and conveniently, Travis is telling us that we're not done yet. So I see this happen a lot when teams test because it's what they should do. But then the tests happen to be written after the code, and they're deprioritized to hit deadlines. When I see this, that means that something else is missing, and that's confidence. There are no acceptance criteria, so done is a pretty fuzzy concept. Tests are written to match the code that exists, not define what done means, which means that when it's time to deploy, everybody is scrambling because there's gaps in functionality. Things aren't written in a way that can be used in the larger system. So no wonder tests get skipped the next time around. They're skipped because they actually didn't provide much value the first time. But anyways, our managers are tracking code coverage, so I guess we should probably write this test. Quarterly reviews are coming up in a couple weeks, so we need to make sure that we hit that metric. This is basically what we need to do, right? We call our function, and then we make sure that we get back the correct status from sending the invoice. But wait, we have to give an auth token to our function when we call it. Good thing objects are convenient. Once again, we'll just drop that in line, pop it right into the test, and then we'll try to call our function again. And when we try to find a purchase order, it doesn't exist, so we should probably create it in the database. Boom, there we go. All right, we'll use this purchase order repo. We've already got it in the code base. This is perfect. We'll commit it to the database, and we're good to go. But we need to define a couple more values so that we can pass database validation so that we can actually commit this thing to the database. That's okay though, we have this object, so we'll just add them right here. Conveniently, we'd already created the place to do it. So here's the subject one more time. We need a few extra values that make an order sendable as an invoice. So we'll just add those in here too. We already have this object. It's starting to get a little bit out of hand, but that's okay. We've got coverage now. The test is passing. We can ship. And then next week, when we find out that we forgot to do something else important with that invoiced order, well, we have the perfect place to put it. So I'm just going to stop right there. I don't really like the way that this code took shape, but unfortunately, it's something that happens pretty often. This is kind of how development goes, right? We do what's easiest because of the near constant pressure to ship, because we want to go home, and because we're human. We do what's most convenient at the time. So that means that we're going to extend and follow patterns that are already present in the code that we're trying to change. We'll add another then to a promise chain that's probably too long. We'll nest a function inside of another one because it's the easiest thing to do. And we'll add a property to an object that's already a bit too massive because it already exists, because it's the most convenient thing to do. There's a platitude that you've probably heard as a developer, and that's that we read code however many times more than we write it. It does feel truthy, but I think behind that statement is a bigger statement, that regardless of frequency, what do you remember about the last time that you had to change code? I personally remember the way that it made me feel. Which emotions would you feel if you stumbled onto that code that we just wrote together? I might feel upset and wonder why that person was so lazy, why I don't understand what's going on. and why I don't have the confidence to make the change that I need to make. But the trouble is, when I ask questions like that, I already know the answer because I've done it before. I've prioritized short-term gain. I've done the things that were easy and convenient. Sometimes it's good, like if we need to test viability of an application. We're not sure it might live until tomorrow, so we need to test that as quickly as possible. But sometimes it's bad, like when we try to save our own skin because our team doesn't really understand the word estimation. Eventually, though, teams prove that their software can make money, and they start to think more long-term, or maybe they're getting frustrated because change is getting slower, things are breaking more often, and it's hard to bring new people onto the team. And this is my favorite time. This is when the real learning happens, because the team right now is hungry for improvements. So if you're at this point, we should talk because I love helping teams like this. Right about now, a light bulb goes off and people start using words like quality, changeability, readability, and they lament all of their past decisions and wish that they could just start over and rewrite their software from scratch. Unfortunately, words like quality, changeability, and readability, they're very subjective and they change from person to person depending on their experience level, their background, I don't know what talk they happen to watch before lunch at SCNA. So if we can't just use those words, what can we do to be a little bit more objective when we're trying to make code better? One thing that helps me is to think about signals and noises. I try to amplify signals that help the team understand what's happening in the code because everything else is just noise that's getting in the way of our understanding. And this is it. This is the most important thing that you can do. Boost signals and reduce noise. And there are a lot of techniques for getting this done. We're going to talk about a few of them later in this talk, but if you just remember one thing, remember to think more about signals and noises. So let's do that. Let's think about signals and noises as we try to fix the mess that we just made. Let's boost the signals that are already present in that code. We'll start by looking at the function name. This should be the first signal because when somebody is exploring our code, it'll act like a signpost. It'll tell them what's coming up ahead. It'll give them an indication of what's happening inside of this function. So that means it needs to be clear about what's happening in the function. Does this function name give that kind of confidence though? Nope, I'd say it doesn't. Here's a better example of what this function could be called. Maybe send new invoice. Although a name is extremely important, it is just the beginning of the story. After clear naming, the most important thing that you can do is be clear about the type of function that you're creating. Because a function should do one of three things. It should coordinate, it should calculate, or it should control. So choose one. Here's some examples of what that means so that we can start to understand how to use them a little bit better. Here's an example of a coordinator. A coordinator is responsible for creating a set of actions, for calling other well-named functions. It manages interactions and that's it. And just like in real life, a good manager isn't splitting time actually doing the work. They're spending all of their time supporting and coordinating the team, just like this function is coordinating the actions within it. This is a calculator. This example is pretty easy to spot, right? It's doing a mathematical calculation, but it's not the only type. What about transitions between domain concepts? So the idea of calculation doesn't just have to be limited to math. We're extending it here to calculate a new type of object in our system. So to talk about controllers, I think it's best to start with a bad example. And this is one. This is a conditional. I hate conditionals. They mix function types and they create a confusing situation. When you use conditionals, there's one function and therefore one test to document that function that's responsible for knowing all of the available code paths within the application. Choosing the correct code path based on the data structure of the objects that it's conditionally checking, and actually performing the next step. That's a lot of responsibility. And the worst part about conditionals is that they tend to breed, because the most convenient change when you have a gnarly conditional is to just make it worse, right? Add another conditional branch, or add some more logic inside that block that's doing the things, because that's the most convenient thing to do. Here's another example of a controller. This is much better. We've created an abstraction here, although it's a naive one. The important thing that's happening here is that now we're allowing each branch to only understand about itself, right? There's one function that's responsible for controlling the flow of the application, and that's it. It uses other well-named things to accomplish its goal. So those are the three types. We need to choose one for that function that we just wrote together. So which is it? If we zoom out and look at it holistically, I can't really tell. It has a lot going on. It's got a little bit of each of the types. However, if we look back at our original goal when we were writing the function, we want to find a new purchase order, and then we want to send an invoice for that order. So when we look at it like this, it's clear that it should be coordinating these two actions and anything else that's needed to get that done. But then when we look at the entire function again, highlighting those two little pieces, they're lost, right? They're completely buried by noise that doesn't make this type of function clear. What we need to do is extract all of the noisy pieces into other smaller units that can then be coordinated by this function. This is the perfect candidate, right? When we create that query object, it's noise, it's distracting. We don't know what kind of object it is because it doesn't have a name, and it's about 25% of the real estate inside of our function. And then what about later on, when we extract our order from the result, and then when we set that innocent status value inside of our order? Well, that's noise as well. The extraction is fluff, it's getting in the way, and we have absolutely no idea why we're setting that value. It's not clear that we're transitioning to a new domain in our code base. It's just a lot of noise. And the same is true at the end when we update the status on the result that we are returning. And finally, the noisiest part about this function is its shape. The shape of this code is super noisy. It's adding a ton of cognitive load and making it very hard to understand the current scope of each variable and how things are interacting with each other. So this happened because we can create inline objects, we can manipulate them with these, and we can nest functions with just the tab key. But that doesn't mean that we should do those things. It's too convenient to do the things that produce noise. So how can we amplify the weak signals that are present in our code base instead? We do that by focusing on what a function is doing. We do that because code should communicate our intent. Because the next person to read our code isn't going to be plugged into our current thought process. And even if you do pair program, a lot of context and nuance is lost forever to time. Functions aren't a folder in a filing cabinet. They're not a place to store procedural actions. Give those actions a proper name. Inline objects don't communicate intent. They're really just a grab bag of properties. So give those objects a proper name as well. Names are the best way to communicate intent because they amplify signal and they give meaning. So that means we need to add some names into the function that we wrote together to amplify its signal and to give it meaning. First, we'll extract the creation of that query object. It's going to become the first name in this function. Now it's clear that we're looking for mySaleDesignWoot. And the information about what that means, well, it's encapsulated with a proper name in our system. And we've amplified its signal in our code. And we can do the same thing inside this function. We can give a name to the confusing transition and domain concepts. Now we know what's happening. It's clear that we're transitioning to a new domain, one that has a name. And then the confusing status shuffle at the end, that can become a name as well, to give clarity to the interaction. So one more time, one more name. And this is it. This is the magic. This is how you start to clean things up. You give confusing things names. You boost the signals that are already present in the code that you've written. Naming is one of the hardest things that we do as a developer, but it's definitely the most valuable thing that we can do to amplify signals and to reduce noise. So we've gone through and we've given some really awesome names to our code, but they're still pretty hard to see. We need to make it clear that our function is coordinating these other well-named actions. The function's type is a coordinator, we have decided after all. So we need to boost that signal that helps us understand what's happening inside. The problem is we have many levels of scope to deal with, and all of those levels are noisy. Since we've decided that we should coordinate the actions of others, we need to create a clean, flat function. But right now, it looks kind of like a bird's nest. Some of the actions in the pipeline are asynchronous, which means we need to use promises, so we should probably structure the entire pipeline around a promise chain. So that means that our goal will be to make each step a well-named transition in the pipeline. So we'll start our chain with the incoming auth object, and then we create the query object, and then we find the correct purchase order for that query object. And you see what's happening? Now the code's starting to read like English. And the next two actions become the next two steps in the chain. Here, instead of nesting our function, we can use promise.all to pass along that result that we're going to need later on. Promise.all ensures that everything is resolved before the next continuation. That means that the next step will just automatically have everything that we need. And it's going to be a little bit more clear that we're passing the result all the way through until the end. We'll keep it up by flattening out the last section in this function as well, flattening out the last block. And this is much better. Now we have a flat pipeline, something that acts almost like a boring list of instructions, and that's pretty cool. When a pipeline is boring like this, that means that the differences on each line, they become our signals. We're boosting the signal that tells us the next step, the next transformation in our function. And that is the key. Even though it's tempting to collapse a couple of the smaller little details, don't, because that makes the pipeline less boring. It distracts us. It focuses our attention on the minute details rather than the overall picture. So even though it is boring, there's still room for improvement, because those important differences between the different lines in our function, they're still kind of buried by a lot of words and symbols that are getting in the way of just seeing those actions. So the final touch will be to remove as much of that crud as we can. First, we'll start by using arrow functions within our continuations, and we'll just drop them when they aren't needed at all. And this is going to reduce a lot of the noise around function declarations, allowing us to focus on the next step in the continuation. And lastly, we'll bring in a library called Bluebird to help us out as well. So when we start the chain with a new Bluebird promise, that gives us access to some cool operators provided by Bluebird, like spread, which takes place of the noisy promise.all. Gives us a single operator to work with, and that's one of the powers that you have in a functional language like JavaScript. This leaves us now with a clean, beautiful, boring pipeline. We're actually drawn to the differences on each line, and that's the magic. We are naturally attracted to the signals when we scan this pipeline, and that's pretty cool. The values that we care about are front and center. They're telling us what's happening inside of this function. Of course, it's important to boost the signal to reduce noise and to give useful names to our production code. We all know that, but do you always see tests getting the same kind of love? I don't, and maybe that's because it's too convenient to rush through the test, especially if you test after the code is written, because you already know it works, right? So what's the test doing at that point? It's just hurting your timeline. And if you take too long testing code that's already done, well, then you get to have an awkward conversation about why. So that means that maybe the idea that tests are code just doesn't cut it. What helps me is to, instead of thinking about tests as code, think about them as documentation. I treat them like the lab journals I used to write in high school science class, where I would meticulously describe my experiments, where each test records my hypothesis about how the code should function under well-defined conditions, allowing team members to understand what's going on. Thinking about tests like this helps me care a little bit more when I'm writing them, and maybe it'll help you too. It gives my tests a little bit higher purpose. and helps me use them to focus my design. And this is one of my favorite things about testing, so we should talk later if you would like to chat more about it. So here's that messy test again. Let's give it the love that it deserves. Let's treat it like documentation. So we'll start with the test description. Just like a function name, the description is the first signal. It's like the signpost. Does it accurately describe the experiment that's being performed? Does it tell everyone what our hypothesis is about the way that our code should act? Or is this test description just noise? One of my favorite things to do is to use real words in my test descriptions. And now the description reads a little bit like English and helps everyone understand what's going on, what's being tested. But also like a function name, the test description is just the beginning of the story. Next, a test needs to have 3 distinct sections. So each section should be clear, it should be boring, and it should be easy to understand and easy to distinguish from the rest. First we arrange, and then we act, and then we assert. Once again, we want to try to keep it simple and boring. This is our current arrange step. It's a mess. Which parts of the input actually control the conditions of our experiment? That's it, just these 3 little lines. These 3 little lines are the signal that we need to boost because we need to make it clear that these lines affect the way that our unit behaves. They affect the way that our code works. They're the things that actually matter in our specific unit. So these should be the only values that we see in the test setup. Unfortunately, they're just a very small piece. So after we arrange, we act, we perform our experiment. This is where we actually call the function that we want to test, our subject under test. This entire step should be the signal, but it's being suffocated by the inline creation of that auth token when we call send new invoice. What we need to do is try to slim it down to focus on what the action is. And then finally, we assert that our hypothesis was satisfied. We ensure that our code works the way that we expect it to. The signal here will be the actual values that you're testing. So don't let it be suffocated by anything that tries to manipulate the results to make them more testable. So if those little pieces were the signal, I guess that means everything else here highlighted in red is just noise. The same thing happened in our test. We let convenient inline objects and distracting details weaken the signals in our code. In order to make it better, we need to isolate the inputs that directly affect this test. We don't really care about the extra values, and in reality, they probably shouldn't even be in this test, but that is another talk entirely. What we'll do here is use a factory to create the object that we need with only the values that we care about. All of these extra little noisy fields, they can be merged and out of sight, centralized in one place in the code, and this boosts our signal. This highlights the input that actually affects our unit. We can define a variable for the auth token as well. When we do this, we document its purpose and we give it a name. We tell readers of this test what our function is expecting when we call it. And this boosts the signal in our act step. Next, we can use variables for the things whose value is important across multiple parts of the test. When we do this, we make it clear how data is shared between different parts of the test. At a glance, you can tell where things are used. And actually, the values, they really don't matter. We just want to see how they're used, not what they are. So our last step will be to pull them up out of the test. So now we have 3 distinct sections. Each one is separated by exactly 1 line. And what we do is we arrange the controlled conditions of our experiment. Then we act out our experiment. And finally, we assert on our hypothesis. It's also clear which values in our input are actually used in the function that we're testing. That's pretty cool. So after refactoring that awful function, I am feeling much happier. And I know the next person to change the code will be happier as well because they'll be able to understand what's going on. Now when I see a mess, I know that my job is a little bit more important than just delivering a feature. I know how to clean up the mess, and I know how to teach others techniques to clean it up as well. And that's not something most people have the confidence to do. And that's what I want all of you to take away from this talk. You've seen some of the techniques, you've seen their value. Have the confidence to help others do it as well. So to recap, this is our before. This is what happens when we blindly accept conveniences just to go faster. Now you know what's wrong with this code. It's noisy, it's missing a lot of important names, and it doesn't have a clear type. And most importantly, you know how to fix it. You know how to take that mess and turn it into something that serves those noble goals of quality, changeability, and readability. You can communicate intent by adding names. You can boost the signal of those names by giving your function a clear type, and you can reduce the noise that obscures the important things in your function. This is our test before we fixed it. It's got a lot of the same problems. It doesn't have clear sections that define the steps of the test. It doesn't document how the inputs to the function affect the way it behaves, and it's overwhelmed with inline objects. And you also know how to fix it. You can use names to signal important pieces of data. You can document the inputs that affect the outcome of our test, and you can ensure that your hypothesis was satisfied under controlled conditions. So boost signals and reduce noise. Thank you for spending your time with me today. I hope that we get the chance to talk sometime this afternoon. If anything that I mentioned resonates with you, please send me a message on Twitter or email me so we can start a conversation. Also, Test Double is growing, so we've got some amazing things coming, so if you'd like to be a part of them, please try to join our team. Thank you.